Welcome back, Logan. Good to have you on another installment of Math from Your Couch. Today we're going to extend the topic that we were talking about in the last video, where we're talking about the segments and their relationships with the circles. So how the segments interact with each other in circles. Today we're going to focus on two occurrences. Both of them happen outside of the circle. So what happens when you have segments or lines that intersect outside of the circle? Our first example, or our first scenario, is something that kind of looks like what you're looking at here. You'll notice that you have two secants. All right, so we're taking a look at two secants. That just means two lines that are intersecting the circle twice. So this line intersects the circle twice, once over here and once over here. And the second segment intersects the circle twice, once there and once there. So we're going to call those things secants. Now, what I noticed, or what we're going to need to notice, is that these secants actually have parts to them that we want to be familiar with or learn how to talk about them. So the entire secant is what I have here in blue. Okay, that's going to be important. We need to know how long the entire secant is. And then we have the piece of the secant, the segment that is outside of it. So I'm going to call the yellow piece outside, and I'm going to call the blue piece the whole thing. All right, so we have the outside portion, and then we have the entire or the whole secant. Same thing is true about the green. The green is the whole secant, and then the purple or pinkish thing right here, we're going to call that the outside portion of the secant. Now, anytime you have two secants intersecting each other outside of the circle, the relationship is going to be that the outside portion, the part in yellow, times the whole secant, the entire secant in blue, is going to equal, when you multiply them, is going to equal the other secant's outside times its whole segment, the whole secant. And this is the formula we're going to want to use. All right, so let's take a look at our first example. So our first example, what we want to do is we want to recognize what's outside and then the entire secant. So outside of this segment here is 5. So I'm going to say 5 times. Now be careful. A lot of people will want to write down x. They just want to say 5 times x. And remember, it's the outside times the whole thing. So we have to think about how long this whole thing is. Well, I would add the 5 to the x. So I would say x plus 5. And that's the entire secant. So I'm going to say 5 times x plus 5 is equal to, and then I do the same exact thing down here at the bottom. I'm going to say the outside is 6 times the whole thing, which is 6 plus 4. Now we know that 6 plus 4 is 10, so we're going to say 5, distribute 5x plus 25. So it's just distributive property over here, equals, and then this is 10, so 6 times 10 is 60. And now we're going to want to solve this equation here by taking the 25 away from both sides. This gives us 5x equals 35. And then we divide both sides by 5, and the result is that x is equal to 7. Okay? All right, so let's take a look at another example using the same exact idea. What we have here is the same exact thing. We have two secants intersecting each other outside of the circle, and we apply the theorem, the property, and it's that the outside, which is 5, so we're going to say the outside, which is 5, times the whole thing. Now, we're going to have to add the 5 to the x plus 9. So we're going to take the 5, and we're going to add it to x plus 9, which is x plus 14. So I can write down x plus 14. Now, for those of you that are like, what did that come from? Just remember, the whole secant is 5 plus x plus 9. That's the entire secant. So if you wanted, you could write it like that, 5 times that. But then you'd want to simplify 5 times that, which is 5 plus x plus 9. Simplify it by adding the 5 and the 9, is equal to, and then we have the outside here, the outside, which is 8, times the whole secant, which comes out to x plus 8. So 8 times x plus 8. And then we solve the equation. We distribute here. We get 5x plus 70 is equal to, and we'll distribute here, 8x plus 64. And then we're going to want to solve it. I'm going to take the 5x away from both sides of our equation, showing a little bit more work than last time. This gives us 70 is equal to 3x plus 64. And then we'll subtract 64 from both sides. 70 minus 64 is 6. So we have 6 is equal to 3x. Once you divide both sides by 3, we end up finding out that x is equal to 2. All right, so this is our first scenario. It's when you have two secants that are intersecting each other, and the relationship is that the outside times the whole thing must equal the other outside times the other whole thing. Now, our second scenario is going to look like this. This is no longer two secants intersecting each other, but one of them a secant because it intersects the circle twice, and the second one is a tangent. So let's color code that. We have when a secant and a tangent intersect outside of a circle. Now the formula is that the tangent to the power of 2 is equal to the outside portion times the whole secant. So you'll notice that the secant still follows the same exact rule that it had in the last two problems. It's the outside portion times the whole thing. The only problem is that there is not an outside and a whole thing for the tangent. So we're just going to say the tangent is going to get multiplied by itself. So we're going to multiply the red and the purple, the outside and the whole thing, and then we're going to multiply the blue by the blue. So everything's going to get multiplied by something, it's just by what? The tangent gets multiplied by itself, and the outside of the secant gets multiplied by the entire secant. Okay? Now there is an alternate form of looking at this formula. One thing you could do is you could say that the tangent, right, the blue one, is the geometric mean of the outside and the whole secant. Now, I only suggest this if you would remember what the geometric mean was of when we were looking at similar triangles, specifically right triangles. And the reason I think this is important is it can set up that formula. Remember, the geometric mean is the thing that's going to get multiplied by itself. It's the two things that are going to show up twice. And then the extremes are the outside and the whole. So I wrote the outside and the whole as my extremes, and then I would write my tangent as my geometric means. Once you cross multiply, you'll notice that you get tangent times tangent, or tangent squared, and you'll get outside times the whole, which is what you have right there. All right, so let's take a look at an example. Our first example, we have tangent, which is 15, and a secant, which is x plus 3. So I'm going to go ahead and highlight the entire secant, which is x plus 3. So we're going to say the tangent is going to get multiplied by itself, and that's going to equal the outside portion of the secant times the entire secant, which is x plus 3. And then now we simplify it. 15 to the power of 2 comes out to 225, and then we distribute the 3, so we get 3x plus 9. We're going to subtract 9 from both sides of the problem, and this is going to give us 216 is equal to 3x. We'll divide both sides of the equation by 3, and we get 72 is equal to x. So this part of the secant is 72. Let's take a look at one last example where we have a secant and a tangent intersecting each other. In this one here, the thing we don't know is the tangent this time. So remember, we have to find out what the whole secant is. So in this problem, the entire secant is 9 plus 7, or 16. So we're going to say the tangent times itself, so the tangent to the power of 2, is equal to the outside amount, 9, times the entire secant, which is 16. Now 9 times 16 comes out to 144, so we have x to the power of 2 is equal to 144. To solve this, we're going to take the square root of both sides of our problem, and we get x is equal to 12. All right, so if you have any questions, go ahead and give me an email or hit me up on Google Classroom, and I wish you the best of luck. Talk to you guys soon.